Hello everyone. In today's lecture, we are going to study the Rodrigue formula of Legendre polynomial. What? Rodrigue Rodrigue formula for Rodrigue formula for what? Rodrigue formula for Legendre polynomial. Alright. So the Rodrigue formula says Pnx is equals to 1 upon 2 to the power n factorial n t to the power n upon dx to the power n x square minus 1 to the power n. So this is our Rodrigue formula, and we need to derive this, right? So just say y is equals to x square minus 1 to the power n, all right, as we can see here. So say this is equation 1 on differentiating 1 with respect to x. Differentiating equation 1 with respect to x. So this will give me what? Dy by dx is equals to n x square minus 1 to the power n minus 1 will give me 2x only. Alright. So say this equation 2. On multiplying what? X square minus 1 both the side. Both the side will give me what? X square minus 1 dy by dx is equals to here 1 power x square minus 1 to the power n minus 1 multiplied by x square minus 1 into 2x. Just simplify this right hand side will give me x square minus 1 dy by dx is equals to n x square minus 1. Here only residue will be n, alright, into 2x. Good. I know this is my what? Y. I'd assumed what? Y equals to what? Y equals to x square minus 1 to the power n. This we had already assumed. So just write x square minus 1 dy by dx, which is equals to 2n x into y from here. So the equation is in this form. Alright. Now if we can see here, we need to differentiate this how much time? N times. Alright. So differentiating say this is equation 3. Differentiating equation 3 with respect to x for how much time? N plus 1 times. So we will use the Leibniz formula by using Leibniz formula. for generalization. So if we remember, what is Leibniz formula? T to the power n u dot v must be your how much? U t to the power n into v plus nc1, differentiate of u with respect to d, and d to the power n minus 1 with v plus so on. So we need to calculate what d to the power n plus 1, for which x square minus 1 dy by dx on the left hand side, and for the right hand term 2n is constant, so it will be d to the power n plus 1 x dot y. Alright, this we need to calculate by this formula, Leibniz formula. So this will give me what? First term u as it is x square minus 1 to the power n plus 1. Already this is one time, so this will give me d to the power n plus 2 upon d to the power x to the power n plus 2 of what? Y plus n plus 1, because here n is equals to n plus 1, c1 just 2x from here, y 2x, just differentiate first u du, so it will give me 2x. Then after this will give me dn plus 1 upon d to the power x n plus 1 y. Alright, plus n plus 1 c2, only two quantity left, d to the power ny upon dx to the power n. This will left, and the third upcoming term will be 0 if I differentiate 2, because next term will be 0. So the only we will get three terms, which is equals to 2 to n common here, x dn plus 1 upon dx to the power n plus 1 into y plus n plus 1 c1 1, because just of x d to the power n y upon d to the power x n. Alright, now just simplify these combination. Alright, so we will have x square plus x square minus 1, x square minus 1 d to the power n plus 2 upon d to the power x n plus 2y plus n plus 1 2x d to the power n plus 1 upon d to the power x n plus 1, this is y, plus the second term it will be n plus 1 upon factorial 2 multiply by 2 this two term d to the power n y upon d x to the power n. Good. And the right hand side must be 2 to the power n x d to the power n plus 1 upon d to the power x n plus 1. This must be n plus 1, alright. N plus 1 y plus this term will be n plus 1, n plus 1 d to the power n y upon dx to the power n. So this we will have. Now simplify this equation. So this will give me what? 1 minus x square. Why am I doing this? Just I want this equation in terms of our differential equation of Legendre polynomial. So differential equation for Legendre polynomial was 1 minus x square dy upon dx square minus 2x upon dy upon gz plus n plus 1 y equals to 0. So for that, I just rearranging this. I took out a negative from here. So this becomes n plus 2 upon dx to the power n plus 2 into y minus of 2x, this term. Alright, and this will give me what? D to the power n plus 1 and d to the power x n plus 1 into y plus, and 2 and x is cancelled out, okay, from here. So the only quantity left is only 2x minus of 2x, and this, if I, this will cancel out here. Then if I take it as, if I took this to the left hand side, this will give me only n plus 1 dn upon, just rewrite, d to the power n y upon d to the power x, and equals to 0. I had just simplified this equation to here. Now just to simplify, put d to the power n upon dx to the power n y is equals to z. So this equation says this is the fourth equation. So equation 4 become, equation 4 will change to what? 1 minus x square d2z upon dx square minus of 2x dz upon dx plus n plus 1 z equals to 0. So this is nothing but our Legendre differential equation. Legendre differential equation. So we know the solution for this right here. Therefore, its solution is given by what? Z equals to c p n x and I know z is your d to the power n y upon d x to the power n. We had assumed this one as z. This is equal to c p n x, and I know y is my d to the power n d to the power x to the power n. Y is my x square minus 1 to the power n equals to c p n x, where c is some constant. Now here put x equals to 1. Put x equals to 1. So this will give me d to the power n upon d to the power x to the power n, x square minus 1 to the power n will give me x equals to, at x equals to 1 must be c pn equals to 1. So we know pn1 equals to 1 from the recurrence relation. It is one of the recurrence. Pn equals to 1 equals to 1 for pn. If x, this will give me 1. This is one of the recurrence relation. From the recurrence relation, we had concluded that pn and 1 is equals to 1. So from here we can say c is now t to the power n, because pn1 is 1, so I removed this one, so only left quantity is c. So constant c is equal to d to the power n upon c x to the power n. Here I can write it as what? This as x minus 1 to the power n and x plus 1 to the power n. Alright, where x equals to at 1. So on expanding this, we will get x minus 1 to the power n factorial n plus n. Leibniz, same with the Leibniz formula. D to the power x minus 1 to the power n, tn minus 1 x plus 1 to the power n, up to where? Up to factorial n x to the power 1 plus n, where x equals to 1. I had expanded this with respect to what? left this formula. So C becomes, from here we can see, C becomes only 2 to the power n factorial n. Just put x equals to 1 in this equation. So we will get factorial 2, factorial 2. Alright. So we know, now we know d to the power n upon d to the power x n, x square minus 1 to the power n is equals to, we know this was C and here was p and x. Now just substitute here. But d to the power n upon dx square n x square minus 1 to the power n is equals to 2 to the power n factorial n p n x. So now just rearrange this, find out the value of p and x is how much, 1 upon 2 to the power n factorial n d to the power n upon x to the power n is x square minus 1. So this is what our Rodrigue formula. Rodrigue formula for Legendre polynomial. Alright, here if we can see, if we put n equals to 0 here, so this will give me p0 of x will give me what, here this is 2 to the power 0 factorial 0 d to the power, this will give me d to the power 0 is 1, so here we'll get x square minus 1 to the power 0. So simply we can see this term only 1, so p0x will give me 1. Alright, now put p, sorry, now put n equals to 1. So for n equals to 1, this becomes p1x equals to 1 upon 2 to the power 1 is 1 factorial 1 d upon dx x square minus 1, which is equals to 1 upon 2. This will give me 2x, this multiply, this will give me x. So p1x is x square x. So for n equals to 2, for n equals to 3, we will can calculate. Now if we see this in, if we see this in programming, so we know the, we know pnx equals to 1 upon 2 to the power n factorial n, we will write factorial n is here, d x square minus 1 to the power n up to n factorial. Just we had created a function. Alright, now just let me copy this. I had already created this one. So for the value of n, for the value of n equals to 0, there must be what, and for n equals to 0, px must be 1. Just we will check. So for the value of 0, your px is 1. Now for the n equals to 1, n equals to 1, it must be x, it must be x. So we will see. So for the value of 1, it must be x. Now we will check for second value n equals to 2, it will give me minus 1 upon 2 plus 3x square upon factorial 2. Alright, for the value of 3, this will give me 1 upon 2x minus 3. So h we can find a number, n number of value for what, p and x. For, let me calculate for 5. 5 must be 1 upon 8x this quantity. Alright, now if I want to plot this, if I want to plot this, just remove. So first term 1, let me plot. So this will be a straight line. Here p and x was x value from ranging from minus 1 to 1. It's a constant line, good. For x, now for x, for x, a straight line will give me. Alright, for n equals to 2, for n equals to 2, we will check. It will give me a curve, this. Alright, now for n equals to 3, this will give me red curve. Alright, so we can calculate or we can draw n numbers of what plot for Legendre polynomial. So this violet term will be the next. Then after, for the value of n equals to 5, let me just substitute here in formula, and this will give me what, this quantity, this two. Alright, so we can plot Legendre polynomial in our mathematical tool. Alright, so these are the graphs for polynomials of Legendre function, and this is our what, Rodrigue formula. Alright, so in our next lecture we will continue the orthogonal property of what, Legendre polynomial. So this is the Rodrigue formula for Legendre polynomial. Thank you.